Hello, so today we are going to do this problem, problems from weekly contest 337, this week's contest. The first problem, number of even and odd bits. So what this problem says is we get a number n, right? Pretty straightforward, and we want to denote even by the number of even indices in the binary representation that have value 1. So we convert n to its binary representation, we take the even indices in that binary representation, and the ones that have value 1, we count them, and that's the this variable even. For odd, it's the number of odd indices that have value 1 in the binary representation. And the goal at the end is just to return an array with even in the first position and odd in the second position. So for example, 17 binary representation is this one. How many even indices that have value that have value 1? So by the way, you need to go from left to right like this. So this is 0, and similarly here with 1 0, this is 0, this is 1. So this 0 even 1 2 3 4, so 0 and 4th indices contain 1. So these are even indices. So on the even side, we have 2 1s. But the other odd ones, this one and this one, have 0. So it's 0 for odd. So we have 2 0. For the second example, where n equal to 2, the binary representation is 1 0. So this is the first 0. This is index 1. So even only 1, which has in value 0, so number of evens with value 1 is 0, and number of odd indices with value 1 is just this one, which is 1, so we have 0 1 here, right? So that's roughly the idea. Now how do we solve it? Well, the first simplest solution is just to do convert to a binary representation using Python's binary function. So that function will give you a string binary representation of n. Now this here will give us, for example, for 2, it will give us something like 0b, 1 0. For 17, it would give us something like this. So we need to just remove this 0b here. So to do that, this will be a string. So to get only after index 2, we can just do like this. And this would be s. Now, what we want to do is we want to return a result that has both for even and odd. So let's just initialize it like this. Or we can actually make it a little bit just more explicit. Initialize them both to 0. And then at the end, we want to return an array with both, right? Now, since we said we go from left to right, that means we need to go to for the string, we need to go on reverse order. So just to make this easier for ourselves, let's reverse it. In Python, we can do it like this. So this will basically make the first position be the first from left to right. And so now we can just check for I in the range of the length of s, right? If the index is even, then we know we want to add to even, otherwise we want to add to odd. But we also want to check only if s has value 1. That's the only thing we care about. We want to count the number of those with value 1 for both even and odd, right? So if its value is 0, we don't need to count it. So that's why we check if the at position I, if the value is 1. If it is, then, and the index is even, then we want to increment the number of evens, because this is the number of values 1 on an even index, right? And similarly for odd, if the index was odd, then we just add to odd, and this should be it. So pretty simple, just direct translation of the problem, and this should work fine. But this is a little bit like, so how can we simplify this? So the first way we can simplify it is, instead of having 2 variables here, let's just have a list where the first position would be even and the second position would be odd. And now here you could say, okay, this would be 0 and this would be 1. And then here we just return res. But actually you can see equal to 0, that's actually just the value of I modulo 2. So it's equal to 0 if it's even, it's equal to 1 if it's odd. So actually let's just instead use that and remove all of these 2 checks, right? This simplifies it quite a bit. Okay, let's make sure this still works. And it does still work. Now, this also is first not available in every language, and second, it's slightly not good to read. So how can we change this? Well, to check if a bit is set on a number, we can just use shift 1 by that index, right? And then do and n. So this basically would gives us, this will give us, so let's say if I equal to 3, it will give us all zeros except the third bit would be set. And if we end it with n, remember with n, with and, 1 and 1 equals 1, but 1 and 0 is equal to 0, and then 0 and 1 equal to 0, and then 0 and 0 equal to 0, right? So with and, it will only be 1 if both are 1. And so if the third bit is set to 1, only if it was set, we will get this equal to 1 only if it was set to 1, the third bit in n is also set to 1. So basically this will give us 1 only if the ith bit in n, only if ith bit in n is set to 1. Okay, it will equal to 1 only in that case. So we can actually just use that to check if the ith bit is set. How do we do that? Well, instead of doing this, we can just check if we shift by I and n, okay? Only if this is equal to 1, which in this case it just means equal to 1, we can just do like this, because otherwise it would be equal to 0 from what we said here, right? Then we do this. That way we don't need to check s. Now how do we get rid of the length here? Well, this is binary integer, so we would have only 32 bits, right? And so instead of checking a length here, we can just check all the 32 bits for n, right? So for something like this, it will be padded with zeros. For 17, for example, it would be padded with zeros all the way until it's 32 bits. So for 32, we just check every bit that is set. If it's equal to 1, which means it's set, we just increment depending on whether the index is even or odd. Okay, and now we can get rid of this, and this should be a lot simpler. So let's submit, and that looks good. Yeah, so this is even better because this is constant time of 32, and so overall it's constant time. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you in the next one. Bye.